It doesn't have to be. It's hard. It doesn't have to be because she wrote. I mean, sorry, I'm just telling everyone. She wrote a ton, and it doesn't have to be like it was like a couple pages, right? It doesn't have to be that. It's just finding the best way for you to succinctly, concisely tell me what is up with the data. So, and it's really tough. It's really difficult. So, what I did was like I practiced the homework multiple times, like just trying to write it up. To do that because it's the time constraint is hard. How did we feel about the time on that? Was that enough? Yeah. I think going forward, if it becomes an issue, especially since we're going to be adding the t-test now, it might get a little bit harder. And I know in the past we kind of had a little bit more time flexibility with the amount of time that you're given. So we can talk about that a little bit more. Yeah, so I think that was everything. Oh, okay, one other thing. So because it's a write-up, and when we look at the t-test packet today, you will see like there needs to be certain statistical like data that you have to report. And so when we're doing that, I'll show you in a second, but like making sure to practice putting that like in parentheses, so you have the sentence and then in the parentheses you have like the actual statistic, just to practice for like journal articles and stuff like that, that type of thing. And I'll show you what I mean going forward, because the reporting of the statistics is a lot more important with the analyses that we will be using. Yeah, so any other thoughts about the PE stuff? Is good? Okay, I'm actually going to go get my binder real quick. So if you could go to lab 2 and open the instructions and take a look at it really quick. That's what we're going to be doing first. Okay, and so there's a bunch of, so we're looking at the one sample t-test, the matched or paired samples t-test, and the independent samples t-test. And so for each test, we have a sample data set that is on Moodle as well, and we'll open those. That corresponds with the examples in the packet. And so, where's my packet? Okay, so what can you tell me about a one sample t-test? What is it? Anyone? Right?
Isn't like comparing a sample to a population to see if they're the same?
Yeah, so it's you have a specific value that you're comparing. Yeah, your stuff to. Let me open. Okay. Sorry. Okay, so yeah. We are basically just testing to see if the population mean is equal to specific value. So basically, these are pretty easy because it's either yes or no, kind of. And so, does everyone have the packet open? So if you go to the one sample t-test, so now we're going to be thinking about the null hypothesis using like, so mu, right? Mu means mean. And so thinking about it that way. So the null hypothesis is that mu equals whatever the specified value is. And so, you know, you have it in the notated form, then you have it in the word form. Yeah, so that's kind of how you look at it. And then the alternative hypotheses can either be the two-tailed or the one-tailed. Again, using mu, so mu does not equal the specified value, or mu is greater than or less than that. And so it's important to have that distinction between the kind of notated null hypothesis and the words. Does that make sense to everyone? Yeah? How we use mu? Because by using these statistical analyses, it's like a parametric test, and so we're comparing the mu is the population mean, right? So we're comparing our sample to this population mean. Okay, so yeah, we're going to be, for the assumptions that you've kind of gone over a little bit, so the assumption of normality, did we talk about homogeneity of variance too? Yeah, so as we go along with all the tests, we're going to be adding assumptions, and kind of it's going to be, adding a little bit of that, depending on what we're doing. Super fun. But for this purposes of the one sample t-test, we just have the normality and then the idea of independence within the sample. So does anyone know what that means? Like, in having independence within the sample, like why is that important for this situation?
The various members of the samples weren't influenced, or the various subjects within the sample weren't influencing one another while they were being observed or reporting.
Yeah, and so when we do the write-up, we're looking at the assumptions. So we're going to do, the normality. And then for the one sample, we'll do independence within the sample. And I really like these assumptions because basically there's no way, we just have the data. We don't really know what they did, so we take it on faith. We usually lack enough information to assure this, so it's basically just saying we will take it on faith that this assumption was met by the research design. So that's all you have to say. I don't think any of the problems going forward have a problem with independence within the sample, or as we go on, independence between subjects, that type of thing. Does that make sense?
So it's just something that needs to be stated?
Yeah. Yep. Pretty easy. Okay. So for reporting the results, this is what I was kind of talking about. It gets important to have these specific statistics in it, so like the p-value. So for reporting the results of the t-test, we're going to do the t-statistic, the degrees of freedom, and then some sort of p-value indication. And you can do this however you want to do it. I usually just do p less than whatever, blah, blah, and then you can write the exact value. It doesn't really matter to me however you want to do that. Okay, and so when we're doing these statistical analyses now, it's going to be important to address the null hypothesis in your write-ups for that. So you're going to, report these necessary statistics. You're going to determine if you're going to reject or fail to reject the null. You're going to interpret that result in words, what it means in the real world. So based on what the variables are, that type of thing. Yeah, and so then, did you guys talk about Cohen's d too?
Mm-hmm.
Okay, we'll kind of go back to that one again. So then, and this will kind of be a pattern going forward with all the analyses we'll use. So you'll report the necessary statistics, say what you feel about the null hypothesis, state the null hypothesis in real world terms, and then have like an effect size. So kind of those four things are going to be very important, and kind of thinking about the check marks. Have I gotten all these things for this test is important.
The effect size. Okay.
Yeah. Cool. So we can do an example using our data. So we're going to open up data set A for lab 2. Okay, so as you can see, the prompt, suppose that we know, based on the results of a federal audit conducted 3 years ago, the mean cell phone bill across the nation at the time was $70. We wonder if that is the mean now. Okay, yeah. Suppose that we take a random sample of cell phone bills this year and find that the mean bill for the sample is $65. We can ask, is the mean cell phone bill in the population now $70? So we have this sample, but what about the population? That's what we're wondering. So the null hypothesis is mu equals $70. In words, in the population, the mean cell phone bill is now equal to $70. And then we have our alternate hypothesis. So when we're going to be doing determinations about this, you're just going to do the explore feature to get the normality functions, right? So we're going to do explore. And in this case, we're interested in our dependent variable is the bill itself. So you're just going to put that over, check mark all of the necessary things that we've done before, just the same thing. Okay? And then we'll just run it, and you'll get all that information. And so when you do your write-up, you're going to do the same thing that you did for the PE. Just make determination about that. And then note the independence within the sample assumption as well. So to run the analysis, it's really pretty easy. You're just going to go to compare means, and then one sample t-test, and then we're interested in the bill, so we're going to pop that over. And so for the one sample t-test, we have a specific value, so our test value is just going to be 70. So you just put that in, and there is nothing to click right now. You can click things, but so then we just will run it. And so it just pops out with this. So looking at this, what does that tell us? Yeah. So what would you report in your write-up? What would you say?
That the sample mean does not reflect the population.
Mm-hmm. So what are the pieces that you need to write out, that you need to type out?
Well, isn't it saying it's not significant? It's not a significant difference, so we can't reject the null hypothesis?
Yes.
Okay.
Yes. Wait, yes. We fail to reject.
We failed to reject the null because P is not less than 0.05.
Yes. Oh my gosh. Yeah. Okay, so what I'm getting at is yes. So we will report the T, report the DF, and the significance, right? So we're going to say the result is not significant, and then you will, in parentheses, write those. And then we're going to make the determination about the null, right? Like you said, and then make it in the real world. And when we when do we use effect size? So what does effect size mean?
Isn't that like?
Travis, we want to hear your voice.
I'm sure
You're going to talk about an IAD, so you should jump in now.
Effect size is like. I'm trying to think of words other than effect and size to use here. But if you had like a study, it would be like.
You could get there.
It's like effect, like.
So-
So if the difference was significant, how significant was it?
Yeah.
Between 0 and 1, right?
Yes.
And it's like a decimal.
So was it really significant? Was it moderately significant?
Um,
Was it not at all significant?
yes.
Was it minimally significant?
A word that I use based on practicing is magnitude. They use that a lot, magnitude. But what I'm getting at is we have a non-significant result. So what does that mean for effect size?
Noticeable.
Correct. Because we don't have an effect we don't have something that's significant, so we can't have an effect size because that's kind of doesn't make sense. Yeah. Anyway, does that make sense?
Can we go back to where we're looking at where we're saying it's not significant?
Yes. So that's another thing. It's hard with SPSS because you're like thinking p-value, like what does that mean? So it's always going to be sig.
Okay.
So that can be kind of tricky, and it's important to kind of know the difference when you're looking at the statistic or the significance. So sometimes you can get kind of tripped up because you might report the t statistic as opposed to the significance p-value.
So what is it supposed to be under in order for it to be, or what should it have been to be significant?
So this is the number, so it's 0.141. So to be significant, we usually use 0.05
0.05. Okay.
or less. Yeah. So anything under that.
Got it.
Does that make sense?
But I can't think of what I've seen recently, like fairly published research. So it's just I'm drawing a blank right now. But so is it more common these days to actually report the actual p as opposed to the
Yeah, I think so. Like nowadays, people usually report the actual p value as opposed to just saying it's less than 0.05 because like it's kind of like wishy-washy. Like, what does that really mean? And then another thing is that in research these days, you know, I bet you've talked about it in class. Like, effect size is becoming a lot more important because like a p value, like with the central limit theorem, the more people that you have, the more significant effect you're probably going to have because you have more people. So it's kind of like that type of thing. So the effect size gives you a clue into whether it's actually the magnitude is really high or low. Okay, make sense? Cool. So if you have any questions about that, let me know.
So where is the effect size? Is it the sig?
No, so this is not significant, so we wouldn't look at the effect size, but for Cohen's D,
Oh, it's the code.
yeah, Cohen's D.
So we wouldn't just look at the two-tailed significance to see like if it were like point like 0.053 versus like the like 0.0001 or whatever. Like
What do you mean? Sorry.
as far as like the significance doesn't translate over to effect size.
Correct. Yes. It just tells you whether or not you're going to look at it. Okay, so you can close out of this data set and open.
Just to clarify, the significant value there is the p value?
Yes.
Okay.
Yes. Data set B. Okay, so matched or paired samples t-tests. What do these look like and why do we want to use them? What kind of like research designs are yeah. So multiple times over a certain amount of time, making observations at different times. Also, you can also do it where you match or I can't remember if it's which is which. Anyway, you connect people's scores. So if like you're looking at a family, you can match like the mom to the dad and look at their scores together as like a unit. Yeah. So I think.
So is the like if you're looking at someone's score before or a pre and a post test
Mhm.
that's matched also or no?
Yes, yeah. So it's basically trying to connect two different variables, whatever that might be, to each other. Making sure that you have like basically for one person you have two variables that are connected to each other and important that you have both of those scores there. Whereas, if you're looking at, just two different unrelated variables. It doesn't matter if the person's one, like, individual's score or whatever is connected to the other variable. Yeah. Okay, so an important distinction for the null hypotheses for the t-test is that we're looking at the differences between the scores. So it's one score minus another score, right? So the mu of difference scores is equal to 0 is going to be our null hypothesis. In the population, the mean difference between the paired scores is equal to 0, or there is no difference. So we're looking at the difference between them, as opposed to just comparing them to each other. Like we're interested in the actual difference, like as a number. Okay, so then, the two-tailed and one-tailed hypotheses are just pretty straightforward, not equal to 0, that type of thing. So again, with this, we're doing normality, and then for this one, we have independence within groups and independence within the samples. So that's another thing where it's just, we're kind of determining that we don't have a lot of information on it, so we're going to take it on faith that researchers did not systematically link participants within the sample, blah, 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 blah. Right? Does that make sense? Okay, so we're going to go look at the data set. As you can see, so for the prompt, does anyone want to read the prompt? I don't want to read it. Please. On page 9.
We want to determine if depression is increasing over time in the population. We ask if people score on the BDI when they completed the measure in 2002, time 1, differs from when it was completed in 2003, time 2. There are a total of 10 participants that were randomly drawn from the population. Negative difference scores represent a decrease in depressive symptoms, and positive difference scores represent an increase in depressive symptoms.
Cool. So, what would the null hypothesis be in mu terms and words?
Mu of time 1 equals mu of time 2, or mu 2 minus mu 1 equals 0.
Mm-hmm.
In the population, the person's BDI score in 2002 did not differ from their BDI score in 2003.
Cool. Yeah, great stuff. Okay, so looking at the data set, you can see you have the 10 people, time 1, time 2, and then the difference score. So they already made this variable for us, but I just want to show you how to do it using SPSS. So, because basically what we're doing is we're subtracting one from another, right? So we're going to go to transform, compute variable, and it'll bring up this wonderful guy. So we're going to target variable, we'll just name it difference, time, whatever you want to call it. And so we're going to do put over time 2, and then do minus time 1. Does that make sense? Yeah, we're just making a different score. And so when you press OK, it'll just create a different variable for us to use. But they already had it in the data set. So just looking forward, if they're asking you questions like that, it's important to know how to do that. Okay, so I don't think we need to go over the normality thing. You will just look at, oh, actually we do need to go over the normality thing, because for the t-tests, for this one, since we're comparing the two means, the difference, for the normality, we're going to look at the distribution of the difference. Okay, so we're looking to see if this distribution of the difference between the scores is normal, because if it's wacky, that means that we have a bunch of crazy stuff going on. Does that make sense?
What if the differences are indicating a positive, like, correlation to our hypothesis? Shouldn't we see, like, more positive, and wouldn't the distribution should be normal?
That's a good point.
Can you ask it again?
Yes.
I see what you mean, though.
I mean, I was just saying, if we're looking for normal distribution, but if our difference in time result is indicating positive correlation, meaning that there's less depressive symptoms, shouldn't that be reflected in our distribution as in not normally represented, as in more skewed towards the positive?
So I do have an answer to that, though, because, you know, thinking about, like, the bell curve or whatever, like, the idea is that there's, like, you know, the normal, like, average score, average whatever, and then there's outliers. And so all it's saying is that the variance between these scores should follow kind of that curve. So there's going to be people who have a lot of difference. There's going to be some people who have no difference. Do you know what I mean?
Like, even if they all show positive,
Yes.
then within the positive it should be.
Yes.
Okay.
So it'll, you know, there'll be variation that isn't like someone's doing really, really, really awesome and someone's doing really, really, you know. Does that make sense? Okay. Okay. So the way that we do this is, we're gonna go up to analyze, compare means, and then paired samples. Cool. So we're going to put time 1 into this box. Oops. And then time 2 will go there. And we don't have any options to do either. So it's pretty easy. And you can just click OK. And so it'll pop out with our statistics. So looking at this, we see we're going to look at the t-score, or the t-statistic, the DF, and then the significance. So this is not significant. So therefore we fail to reject the null hypothesis and state that in the population, the mean difference between paired BDI scores is 0. Yes.
No, go ahead, because my question's about normality. I was looking at the sig value and the up to paired samples correlation.
Mm-hmm.
So what is that referring to?
I think it's seeing how correlated the scores are with each other, but that's kind of confusing to me because I don't know, it's the same person, and why you would expect the scores to be, I don't know.
Isn't that the correlation value? Isn't that reflective of like an effect size?
Yes, but like in some cases. So like what I honestly don't have a determination about why this is here, to be quite honest, because it doesn't make sense to me why they would need to correlate the two to each other, because yeah. So we'll revisit that because I don't know why.
Well, maybe it's for validity.
Yeah.
In like test taker.
Yeah, I don't know, and because it is significant, so I don't know. Oh, and so this is another good thing. So it's not significant, right? So this is when we're looking at the BDI, the depression scores. When we're looking at treatment, like you may have. So this is the first time was 20, and then time 2 was 21 point whatever. So like these scores are different. It's just determining whether it's a significant difference, right? So that's an important difference to make between the scores being actually like they're different, but are they significantly different? Cool.
And for the normality, in this case, since there's only 10 people, we would use the Shapiro-Wilks.
Yes.
Would we still have to report the Levines? No. The
No.
the vodka one? Smirnoff.
Right? Yeah.
Vodka one.
No. So you can use one or both, but one is good enough. Does that make sense? Okay. So yeah. Cool. Any questions about paired matched samples? Okay, we're gonna move on to independent samples.
Did we actually look at the distribution of this?
No, so we did not run it this time, but you will, just to save some time. Okay, so independent samples. So this is most of the time to compare groups. For example, men to women on this score, or independent treatment and control groups on mean levels of depression. So we're comparing different groups that are not connected to each other. So, our null hypothesis, mu1 equals mu2, or mu1 minus mu2 equals 0. So there is no difference between mean 1 and mean 2. Yeah. Does that make sense? Looking at that, it's pretty straightforward. It's important to understand the concept of the null, though, for your write-ups and stuff like that. So if that's unclear, we can always remove that. So again, we do the normality, but okay. In this case, for independent samples t-tests, we have different groups, right? And so for the normality, you can assess the dependent variable for the whole group as a whole. So you have the whole entire group of people, so men and women together. Or, to be especially thorough, you can evaluate normality per group, right? So you can look at the normality for men and normality for women. And so by doing that, you would just put the grouping variable in the factor list. So my idea on this is you can do either. They're both correct. You just have to do one or the other. So you can do the normality of the group as a whole, or you can do normality for the separate groups. Does that make sense? Just to make it easier on you, just do it as a whole. But just understand that to be more accurate, you would look at the groups separate, right? Because there might, the men might be wonky and then women are like normal.
If you were to do that
Like what?
if you were to do that, would you be able to put multiple variables in the factor list and it would break it out separately?
Yes.
Okay.
Yes. Yeah. So, going forward, this is where the assumptions start getting really important, right? So, they're always important. But, so we have normality, and then we have independence between and within groups. So we need independence within the group. So within men, that the participants aren't affecting each other, but also that the two different groups are not affecting each other as well. So there's both of those aspects to it. And so for between groups, random assignment is a really good indicator that is okay. Does that make sense? Cool. So then, homogeneity variance. What does this mean? Does anybody have a good explanation for that?
The distributions are correlated between the two things that we're sampling.
Yes, that's a good way to put it. So basically, just making sure that the two different groups, they have variances that are equal to one another. You know, like that they're not totally not comparable, basically. And so to do that, we use the Levene's test. And so this comes out with SPSS when we do the t-test, so that's nice. You don't have to do anything extra. It'll just come out. This says to do the Levene's test only if the normality assumption has not been met. But for the purposes of the PE and homework, please just do both of them, just so I can see that you can do them. And so this is the same type of determination as the KS and Shapiro-Wilk test. So we want to get a value that is greater than 0.05, right? Because if we get a significant value, that is bad news because it's just bad news. We can't do that. So
pretty much not usable.
yes, yeah. So and going forward, so basically what the assumptions are, we're determining whether or not we should do this t-test or not, whether it's appropriate, because if it's not appropriate, then our data is kind of defunct, like we can't use it. So basically, either the assumption of our normality or homogeneity variance has to be met. So you can either have, if one of them is violated and you have the other one, you can go forward, but it's still kind of concerning. But if both are violated, then you probably should be using non-parametric tests.
Is the Levene's test applicable to all the t-tests that we just did, or just the independent samples test?
Just this one, because you have two separate groups.
So anytime you see homogeneity of variance, it's talking about a Levene's test or an independent sample t-test.
Yes.
Okay.
And this will come up with our other analyses too.
Okay.
Going forward. But yeah, so it's only relevant for independent samples.
Awesome. Thank you.
I have a really good handout that I will try to find that lists all of the analyses that we learn and has these assumptions sorted out. So we have 1, 2, 3, blah, blah, blah for this one, and then so I'll try to find that because it's really helpful.
I think that you'll get to when we do the prompt. But I'm just wondering, so for this specific prompt, the normality assumptions are met, but the Levene's statistic is not.
Mm-hmm.
So is that just saying that you're using the wrong test?
No. So, so you have to have one of those, right? So if the normality, you said the normality is
The normality is good, but
Okay.
the Levene's is significant.
Oh, it's because we're comparing attorneys and stuff.
And I think in the prompt it says something like the attorney's variance was greater.
Okay, yeah. So, another thing about the Levene's test is we're looking at whether equal variances can be assumed. And so when we go look at the data, that'll tell you where to look, what line of data to use to get your statistics. That doesn't really answer your question, but we'll
I
look
can
at it.
just wait until.
No, yeah.
I was just curious.
No, yeah. Yeah. What was your original question?
Well, we haven't even gotten to the prompt yet. I'll just wait.
Okay. Do you want to read the prompt?
Okay. Researchers randomly sent measures to attorneys and psychiatrists nationwide. We want to know if the mean annual salary of psychiatrists differs from the mean annual salary of attorneys. Each psychiatrist and attorney completed an annual salary measure and mailed it back to the researcher.
Cool. So, in the population, the mean annual salary of attorneys equals the mean annual salary of psychiatrists, or there is no difference between the means of blah, blah, blah. So that's our null. Alternative hypothesis is the opposite of that. So yeah, going, we would do the normality for the dependent variable. Do we understand do we want to run that? Or are we good?
So in the prompt, it says that they evaluated the assumption for the entire sample, and I actually separated it, and that's where I saw that they're both individually normal, but they're saying that they do get a significant result for normality, so the assumption hasn't been met if you
okay.
run it for
Both.
all together. Yeah.
So people say that the assumption. Yeah, so I guess that's another thing is it's more accurate when you separate out the groups, whereas together it didn't. Oh wait, together it was not right. So either way, because we didn't have the normality, it wasn't met for the variable. We can. We still want to look at the homogeneity variance.
But so like I separated the factors and normality was fine. So
for each group?
Yeah. I'm wondering what happens. I guess now that brings up two questions. Like you can use your discretion as far as which normality you actually want to say.
That's really interesting because I don't know what to say about that, to be quite honest.
Okay.
Because I'd always thought that when you separate it out, it's more accurate because you're looking at the two different groups.
Together it doesn't make any sense. Like looking at it, it looks just weird.
Okay. Yeah. Okay. We'll address that again.
My original question was like ignoring the prompt and looking at this. If the normality is good, but then the Levine says the assumption is not met for homogeneity variance, can you proceed with the test?
Yes.
Okay.
So you just need one of them. It doesn't matter which one, really. I mean, ideally you want both met, but just that's a good rule of thumb, is one at least. Okay, so why don't we run the data? So data set C, open it. And so go to variable view, and we can go to values and see how the profession variable is split up. It's pretty easy because it's just the two. But when we get to more complicated data, like it'll be important to figure out what groups we're interested in. So psychiatrist 1, attorneys 2. Go back to data view. So we would run the normality, right, for the groups or together. I don't know yet. Compare means and independent samples t-test. Okay, so our grouping variable is going to be the profession because we're looking at the different groups, and those are our independent groups. So define groups. We're just going to do 1 and 2. So that'll say the psychiatrists and the attorneys. Separate them out. And then our test variable is salary. We don't have any options or bootstrapping, so we should just be able to run it. Okay. So we found out that, let's just say that we found out that the normality was normal, right? Whatever, we're good there. So, looking at Levine's test, our homogeneity of variance, we can see that it's significant, and that's bad news, right? So, all that means, since we have our normality okay, is we're going to look at the equal variances not assumed line, because we haven't met that assumption. So if this was above 0.05, we would look at the equal variances assumed line.
So
the degrees of freedom.
Yes. Mm-hmm. Yeah. So does that make sense? It's like an important distinction, but it's not that different. But do you have any questions about that kind of?
Do you know why that changes the degrees of freedom?
Yes. I have to think about it though.
I guess it doesn't matter.
There is a reason, but I don't know.
When Dr. Wadanya was explaining degrees of freedom, the essence of it is to account for errors in the
Yes, okay.
distribution.
Mm-hmm.
I don't know the exact reason for the values, but
Okay, that makes sense because it's saying that we can't assume that the variances are equal, so it's probably accounting for a little bit more error within it. Cool. So
when we're looking at this t-test,
yes.
We're essentially just looking at the two groups and comparing whether or not they're homogeneity. Like when I'm reading this chart right here, I can see that like the Levine's test was significant, so that it means they're not equally distributed individually, right? But then you were saying not to use the first one, to use the second one. So using this, like the variances that are not assumed, what am I reading? Like, how am I interpreting that data now? Like, am I making any sense?
Kind of. So this is like, it's all in the same table, but this is just one of our assumptions, and that's different from this t-test statistic. So this is our actual statistical analysis that we're using, the t-test. And so we're using this to determine one of our assumptions. So it's telling us which area to, what statistics to use. Does that make sense?
Okay, so looking at this sig 2 tilde and having both those values be 0, is that interpreted as being significant?
Yes, yeah. So now that we have figured out which one to look at, we're looking at this one. We can look at this p-value and determine that it's significant. So the mean salaries between psychiatrist and attorney is significant. Yeah. Yeah. And yeah, as you can see, like that's a huge difference. Yeah.
Just switching over to the law school?
yeah, I know. As a cohort.
I'm sure that doesn't reflect the real world either.
Yeah. So yeah, does that make sense?
Yes, thank you. Although if we're reporting this, like, we would say that there is a significant difference, but we've also, do we have to mention that both of the populations were not normally distributed?
Yes. So, okay. So, having a normal distribution and having homogeneity of variance are two different things.
Okay.
And altogether, that is also a different thing than comparing the means of these two groups.
Okay.
Does that make sense?
Mm-hmm.
So they're like separate things. So it's kind of confusing because what normality is like we're looking, does it resemble a Bell curve basically? Is the distribution normal? Can we use this data? Homogeneity of variance is like making sure that the two different groups do not vary too much from each other.
But since we see that they do vary from each other, is that something that we would report?
Yes.
Okay.
Yes. So for the assumptions, you're always going to report on them.
Okay.
So we have 3 assumptions for independent samples t-test. So we have our normality, independence within and between groups, and the homogeneity variance. So you're always going to make a determination about those. and then also bring in the actual t-test.
I actually just read the whole normality assumption,
Yay!
and they do say that when they actually ran them separately, and it was not significant, and they explain why. So I should have just.
Okay.
They did what?
They did what I did and ran the normality for attorneys and psychiatrists and found. So initially they ran it together and found that it was significant, indicating it's not a normal
Yeah.
distribution. But then they ran them separate and found that the reason it had shown up that way was because there was a bimodal peak.
Yeah.
And then when they ran it separately, each distribution is normally distributed. It was just putting them together made a significant difference, which is explained by the homogeneity of variance.
Right.
But they don't really say like what it means. They just say, this is why it's useful to run Explore and do two different groups.
Yeah, but then you have to unsplit the file before running. Obviously, you have to unsplit the file before running the t-test.
I didn't without splitting it. Yeah, I didn't actually split it. I just when I did the normality, I put factor by.
Yeah, I split the file and then had to unsplit it. Otherwise, the t-test wouldn't run.
Mm-hmm.
So none of us are paying attention while you're talking. We're just running around.
That's great. I like it. Does this make sense?
Yes.
Do we have questions?
Just when the significant value is greater than 0.05,
Yes.
you just always disregard the bottom row.
Yes. Are you talking about for
Yeah.
means? Yes.
Okay, thank you.
Cool. So when your homogeneity of variance is met, so 0.05 and over, you just ignore this line. Yeah? So you use the top one. Do you have any questions about that?
And so then, since it is significant, how do we know the effect size?
Okay, so effect size gets a lot easier after this because we use other forms, but we use Cohen's d for this, right? Did you talk about Cohen's d? So, honestly, I can't remember. I'm pretty sure that the homework asks for an effect size because it does like an independent samples t-test. But if you calculate the Cohen's d, you can get extra credit for it. You don't have to do it, okay? Because it's a whole formula, right? Did you go?
Can we not do it in this business?
Yeah, we'll do it. So what you're gonna do, we're gonna go back and run the normality. So we're gonna go to Analyze, Descriptive Explore, and we want to do the factor list for this one because we're looking at the effect size between the two groups, right? So, just gonna click this really quick. I don't really know what all you need for this. That thing. Okay. So, okay, so this is gonna be really fun, guys. I promise. It's gonna be great. I personally like equations because they're kind of fun. So, if you look at the packet, so we have Cohen's d equals mean 1 minus mean 2 over pooled variance. So that's the pooled variance. It's kind of taking into consideration group 1 and group 2 in the variance, right? So to get pooled variance, you do this whole equation on here. It's quite a lot. So, what is N1? It's the sample size for group 1. So what is that? Or what is that value?
15.
Yes, they're both 15. So what is so S squared, what is that?
Variance.
So
51 in the first group.
it's 51?
51.695. If I'm looking at the line right.
Yes. Oh, okay. Also, so right, okay. So standard deviation is S. So in the equation, it's S squared, which is variance.
I said that.
What?
Didn't I say that?
She's just
You
explaining.
didn't explain it.
Oh,
No, yeah. So just like to make that clear is that S squared is standard deviation squared, which is variance. Yeah. So we can just do the 51 point, what is it, 51.695?
695.
And then so for our group 2, 15 is our N.
187.067.
And then 15 plus 15 minus 2. Who wants to do this math on the podcast? It's 28?
Oh,
Wait,
I was
what?
talking about the bottom number.
Travis is a savant.
Yeah,
So
Well, it's
only when I'm tired.
765.73 plus
Over.
oh, that's not. Maybe it is right. 2,618.94.
Oh, wait.
2618. Sorry. 0.94. And that is
It's kind of fun though, right?
plus 2618.94 is 3,384. 3384.67. And then divided by 28 is the square root of 120.88. And that is, where are you? 10.99.
Okay. So we have our pooled variance now. Yeah?
Is that right? Oh yeah. They got something slightly different. 10.93.
Yes. So
Oh, they did 3
we,
digits rather than 2.
what is the mean for group 1 and mean for group 2?
Mean for group 1 is 74.13. And do you want 3 digits or
Two is
decimal or
fine.
2? Okay. And then for attorneys, the mean is 222.26 or 27.
So do you see what we did there? We did the whole pooled variance for the entire both groups. And then we're looking at the mean 1, mean minus mean 2, divided by the variance between the groups, or for the groups, right? And that gives us our Cohen's d. So that's our effect size. Can you do that math?
Yeah, it's well, it doesn't matter negative for effect size, right?
No.
It's negative 13.48.
Wait, what? Ooh, something's wrong here.
It could be, you mean the discrepancy between the numbers they have?
Oh, they did the subtraction backwards, so they had 222.26 minus 74.13. So that's why they got a positive versus negative.
I rounded in one of those numbers inside the square root, so that's why we have different numbers.
I think so. The thing that I'm looking at is for Cohen's d, it's supposed to be between 0 and 1, and that's 13.
That's what they have.
Yeah, they have the same thing.
Oh, they do. Okay, that's good news, fam.
They said from that it's indicative of a very large effect.
Okay, yay. So yes, very large effect size.
I thought it was between 0 and 1.
Me too. Sometimes it's not. Okay, did you have a question?
Just in regards to the formula for
Yes.
fold variance, that's a -2 at the bottom.
Yes,
Minus
-2.
Yes. Okay.
And so this is just saying, this is the N for group 1 and for group 2 -2 because there's 2 groups.
Okay.
So it's kind of,
See, this is what I'm talking about when math is just a bunch of people got really fucked up and said, okay, this is what we're doing, guys.
yeah, I mean,
Like,
Yeah,
yeah, definitely.
this
Anything
kind
for
of-
one is-
makes up for some of the error that might be within it. But does this equation make sense and how you get that?
Does it matter what order the means are in?
No.
Okay.
Because we got this negative, but we're kind of ignoring that, so
Right.
it's just.
Okay.
We got pretty much the same number, just with the negative versus.
Yeah. So, no, it doesn't matter.
So it should be the absolute value.
Yes, you're right. So for the homework, I don't know if it comes up on the PE. I think it probably does. But for either, if you calculate this, but the thing is, so if you calculate it, I want you to do it by hand and like send me a screenshot or like show me how you did it. You can get some extra credit points, or you don't have to do it. It's fine. Do you have any questions about that stuff? Cool. Well, then we are done for today. I'm gonna get you the PEs by the end of the week. So that's the thing. And if you have any questions, you can just ask me about it. So for the homework, if you want feedback on the homework, please send it to me by Monday night at midnight. Otherwise, it's due by Tuesday at midnight, and we will go over the homework in class next week and just talk about more stuff. And then the following week, we'll have the PE again for the T-tests.
Just in regards to reporting the effect size, we can just say it's small, medium, or large. We don't have to indicate what that means in the population.
Yes.
Okay.
What's the cutoff for a large effect size? Is it
I think 0.8.
Oh,
Yeah. And it depends on who you ask, basically. So,
Cool. Okay, thank you.
thanks.